So again, number one, the answer was 9. Number two, the answer was 11. Those equal each other. For 3, still equal to each other. So these are going to be the same. X equals 4. These have to add to 180. So 11x plus 92 equals 180. 11x equals 88. X equals 8. Okay. Here, x equals -8, I think. Yep, those have to equal each other again. So pretty easy connections, I'd say. It was a great worksheet. They got triangles too. Remember the exterior angle has to equal what these two guys add up to. So that question mark is going to be 60. Likewise here, this exterior angle will add up to the two interior remote angles or non-adjacent angles. That question mark will be 70. So again, A5 equals X plus 20 or question mark plus 20. 86 equals 16 plus question mark is X plus 16. Ooh, you are right. Sorry. My bad. Correct. Right. Okay. Here, 140 equals what these two add up to. So 10x plus 20 equals 140. 10x equals 120. X equals 12. Uh, 134 adds up to these two. 14x plus 8. So it's 126. That is, don't tell me, 9. Yeah. Yep. 29. That one's easy. That's 35. That's 117. So that should be 63, I think. Any mistakes so far, or everything seems okay? Everything seems okay? All right. So again, I'll stop here because let's get kind of similar on this a little bit. So these add up to this, right? We talked about it, right? The exterior angle equals the two interior remote angles. 134 equals the sum of those two. We know that as well. That's 14 x plus 8 select for x. Obviously, all the other stuff have 90, 35, or 63. Okay.
I think 1166.
Oh, I could be wrong. Maybe I'm wrong. You're right. You know what? I think I saw a 5. I think it might. I probably need to get new eyesight or something. I don't know what's wrong with me. 6.6. Yeah. No, seriously, like my eyesight's not getting great. So 6.6. Yeah, I agree. Because that's 114. Correct. Good. So we got another page here. Labeling. Okay, this is the part where you guys might struggle a little bit. So in order to keep things easy, I'll abbreviate as core for corresponding. We'll call it AI for alternate interior, AE for alternate exterior, CI for consecutive interior, and just V for vertical. So these are alternate interior. So that's AI. You can see they're inside and they alternate. These are on the inside, but they're on the same side or consecutive. So I call it CI, consecutive interior. These are vertical because they're directly opposite of each other. And this is AE, alternate exterior. So alternate means the alternate, right? You're opposite sides. That's clearly the case for 12 and 15, but they're inside for 12 and outside for this. Another term I haven't really mentioned with you guys, which I think I should talk about. I don't think I've talked about this. Have I used this word before? Transversal. Yeah, I haven't talked about this, right? Yeah. Okay, the transversal is the line that passes both parallel lines. Of course, it passes one, it's going to pass the other. So this right here is a transversal. This right there is a transversal. Those are called transversals, okay? So, yeah. So that's what's happened there. That's the transversal. That's the transversal. And so when we talk about interior, we have the inside both pair of lines, but opposite sides of the transversal. It's alternating. So if it's alternating, it's opposite sides of the transversal. It's consecutive on the same side as transversal. And if it's alternates on opposite sides, sorry, if it's interior, it's inside the pair of lines. Exterior is outside the pair of lines. And then for 16, that's going to be corresponding. This question was some of the exterior angles. Ooh, that's a good one. So if I drew a triangle, all right. So say I call this an angle 1, angle 2, and angle 3. Let me ask this question. What if each of these are 60 degrees on the inside? The best way to answer a question like this, there's more formal ways, but if you want kind of like a quick and easy, a practical way, just be hypothetical. Especially for those who are, I know we don't have any rising juniors in here, but you start doing SAT, ACT preparation, sometimes that's a good strategy. Let's be hypothetical here, right? That makes sense. That could be 6 to 660, right? If that's 60, how large is that angle? Just right next to it, and they're part of a straight angle. Right, and likewise with angles 2 and 3. 120, 120, 120, they all add up to 360, good. Now, what if I adjusted these? If I made this bigger, then guess what? One of these two gets smaller. There's an adjustment, right? Let's say we got 70 and that 50. That gets bigger, but that gets smaller. Or sorry, if that gets bigger, that gets smaller, if that gets smaller, that gets bigger, whatever, you get the point. There's gonna be an adjustment. So what's gonna happen is that each of these are 120 right now. But if I make any adjustments to the inside angles, the outside angles will adjust accordingly. So it has to be 360. So that's always going to be true. The exterior angles always have 360. And by the way, that's true for any polygon, by the way. If you did like a square. So we have a square, right? Let's measure each angle on the inside. Correct, right? Ninety, 90. Each exterior angle as 90 in this case was 90 plus 90 plus 90 plus 90, or 90 times 4, still 360. So that's going to be true for any polygon, by the way. This is true. This is something I think we talked about in the spring in geometry. True for all polygons. So, yeah. Okay, cool. Let's keep moving. Now, the interior, so that's always going to be 180. They'll always be 180. So, if, say I have like A, B, C, angle A plus angle B plus angle C, all up to 180. Okay. Um, okay, last couple, and then we're done. This homework. Yeah, these add to 90, right? Yeah, God bless you. Okay, x equals 28. I think, is that right? Yeah, 28. Then here these add to 180. Yeah, these are excellent practice. So you get 140 plus 2x equals 180. 2x equals 40. X equals 20. Sort of cool. Okay, so let's do this. I was running a little late because I just had some issues that I had to take care of with my parents. So I printed these, but I still need to make photocopies. So what we're gonna do is this. We'll start at Delta Math right now. So we'll kind of flip things a little bit. Let's keep making more headway at Delta Math. We'll do it for me about till about 9:30ish, and then we'll do a lesson. Then we'll take a break and we'll do more lessons. And then near the end, we'll do more Delta Math. I'm not doing the homework quiz also. We're just gonna kind of take a break from that. So yeah, definitely we want to do more Delta Math. So if you guys get out your Delta Maths, I'm gonna come around and see where you guys are. If for those who who finished the extra ones, Jake and now, have you guys finished the extra one, or are you still working through the extra ones?
Oh,
Okay, because I made it pretty.
down.
Yeah, I know. I made it that way. But good. Let me pause this for a moment. Equations. When we're solving system equations, we can solve by graphing or by algebraic means. There are techniques also, which obviously you'll learn later in your math career, but for now, we're just going to focus on graphing, substitution, and elimination. Before we solve a system by graphing, we need to make sure we can graph a line, right? Very important. Can't graph a line, can't really solve a system by graphing, right? Because later in this packet, we're going to be graphing two equations on the same coordinate plane and see where they touch. And again, if you want to do that, you got to know how to graph the darn line. So we know this to be true, right? So when you have something in slope-intercept form, guess what? Just find the y-intercept and use the slope. So for number one, what's my y-intercept for number one? Correct. It's -2. What's my slope?
About 7.
Yep, perfect. So up 7, right 2. And there you go. Okay, here. Down 6, right 1. So we get very good with it. You could just see, okay, 3 is my y-intercept. The slope is -6, which you can think is -6 over 1, by the way. So down 6, right 1. Down 6, right 1. Okay, y equals -5. You have that. 6 fifths x plus 1. It's a little off the graph. You have to go up 6. Right 5. So 1, 2, 3, 4, 5, 6, right 5. 1, 2, 3, 4, 5. So y equals -5, by the way, we have a horizontal line. If you think about it, every point of this line has y value of x. -5, right? Like for example, what's the coordinates of this point? If I think our point right now, 4 comma,
-5.
or 5 comma, -5, or 6 comma, -5, or 2 comma, -5, 3 comma, -5. Every single time y is -5. Why is there no x in the equation? That's because x can do whatever it wants. It's not restricted. Remember, equations are relationships. How do the variables relate? Every single time on this graph, this is a visual representation of a bunch of data points. That's all equations are, it's just a bunch of data. I mean, I could ask you guys a more realistic question. I sometimes think we teach this the wrong way. We teach in a very boring way. I mean, probably a little more sensitive, but if I were to say, like write down your height and your weight, right? Okay, fine. A taller person is probably going to weigh more, right? So we want to see a correlation. But that's data points, and we're trying to make an equation to relate your height and your weight. Better example might be how many hours of sleep you get, and maybe what is your GPA. Now that's very sensitive also, right? But if you sleep more, maybe you have a better GPA, right? Maybe if you don't sleep as much, or I don't know, maybe we see an opposite. But the point being is that when you make equations, you're relating a couple quantities, right? And what am I relating? These things to X and Y. Every single time here, Y is -5, X to whatever. But here, what's the relationship? Apparently, when X is 0, Y is 1. And then every time X goes up by 5, Y goes up by 6. That's relationships, right? So that's all these ever are. They're just relationships. Probably should do a word problem that might be good. Maybe I'll try doing it before we end today. More of the same stuff here. After I do 5 and 6, I'm gonna have you guys try 7 through 12. I'll walk around to help you guys out. So make sure you're comfortable with graphing these. Again, all you're doing, identify the slope, identify the y-intercept. M is 1/4, B is 2. So you're gonna start at 2, up 1, right 4. That's all.
And
Sure, go ahead. Yeah, go for it. Now, here, when it's just a single letter, just locate 5 and make sure every dot has x equals 5. So you have to go vertical because, so don't try to guess or memorize it. Oh, is x equals that vertical, horizontal? I don't remember because the x-axis is horizontal, but I don't know. No, just every time x has to be 5. That's it. X has to be 5. So every single point here, x is 5. Y can be whatever because you don't have a restriction on y. You didn't make it a condition for y, right? Y can be whatever you want. Every single time x is 5. That's it. Okay. So why don't you guys try 7 through 12? I'll walk around to help you guys out. The answers are on the next page. Just so you know, don't freak out. It's not too thick. The next page has the answers. So you can check. And if you don't see a y-intercept, I mean, if you don't see a number, assume it's 0, right? So you assume it's 0.
These are extensions.
Good. Okay. Really fast, you should get this. Yep, wrong. This should be this. This should be this. This should be this. His last two should be this. Up one, right two. So again, find the y-intercept and use the slope. Pretty straightforward. Starting at 5, up 2, right 1, because 2 is 2 over 1, by the way. Okay. All's good? Okay, this next one's gonna take a while. It's like a lot of problems. Like it's kind of crazy. I don't know why there's so many here. I think if we just do like 2 or 3 of these, let's do a couple and take a break. And then we'll come back and we'll do solving by algebraically by substitution elimination. So really fast for number 1. Now you're doing 2 lines, right? So let's get the slopes and y-intercepts for each of these. What's the slope for the first line here? What's the y-intercept? 4. Slope? Y-intercept? Okay, I'm gonna color code, so let's go blue for the first line. So you start at 4. 1, 2, 3, 4. Down 3, right 1. Ah, yikes. Then here, you start at -2. Up 3, right 1. And the hope is that they hit at a point that's pretty easy to read. This can be tough to graph. Actually, I don't like this technique because if they intersect at a fraction, it's kind of hard to tell. But it's pretty obvious they're touching at 1, 1. So what you do is when you solve, you want to give the point of intersection. That's the solution for this algebraically. You want to find where they have what they have in common. Because if I plug in 1 and 1 for x and y into each equation, it will be true. 1 equals -3 plus 4. 1 equals 3 minus 2. It's true. It will work. So we want it. Let's try one more here. Now for this one, I would probably suggest that you get y by itself. I think that's a good strategy. You can find the intercepts, but I think just getting y by itself is probably going to be your best approach. So move the x over and divide by -1. Here, move the 7x over and divide by -1 again. So what I'm gonna do is geez, this is gonna be a little tricky to figure out where they're gonna touch. Okay, I think I got this. Let me erase the other stuff here. This will be our last one. We'll do a break. But essentially, what you're doing is you're getting it helps get y by itself and then graphing it. So go blue for the first line again. X minus 3, up 1, right 1. Yeah. Okay, then that I'll do green. So 3. Well, I'm just trying to do this in my head here. Okay, I got it. So you gotta go up 7, right 1. So 2 and 2, 3, 4, 5, 6, 7. You go down 7, right 1. So it's -1, comma 4. Okay. So we will yeah, Alec, go ahead. Oh, -4. My bad. My apologies. Because I want to take a break, that's why. -1, comma -4. All right, here we go. My apologies. -1, comma -4. You're good. Okay, it's 10 o'clock. Good time to take a break. We'll do I want you guys to practice this. Then we'll do solving, and then we'll do more Delta Math afterwards. Okay. Let's come back in 10 minutes. What? Oh, if you go into the walk-in closets, you know the closet in the hallway? Okay, so where we keep the vacuum, the toilet paper, and the paper towels. Okay, go there right now and okay, so you go to the closet that's across the Legos room, and do you see? So are you there right now? Okay, did you open the door? Okay, your sleeping bag should be in there. He's goodbye. Okay. Yeah. What we're yeah. Yeah, or maybe if mama can text me the hotel if you ask mama or even not or Nana or Papa. Okay. Well, maybe at nighttime before you guys go to bed. How about that? So maybe when you get to bed, when you're at the hotel, you guys can call me, yeah. But you guys drive safe, okay? I'll talk soon, all right? Okay, love you guys. Bye. Bye. Here. Oh, okay, have some. Well, it's funny because you must have more boys.
I do. I have 7 boys.
Guys are big boys.
Yeah, 7 soccer boys.
Yeah, thank you for again for the materials.
Yeah.
Yeah, I'm going to look both my parents have COVID.
Oh,
My
no.
mom can like move it right. Yeah, so like I guess our fault. So I had to like Yeah, I guess. So,
Okay.
yeah, so that's why I was running well.
That's
So-
fun.
Yeah, and I know that Bill Food got COVID already too, so
Who?
I knew a few other people have COVID.
Yeah.
Seems like some, maybe all the traveling and.
Um. The process is a good start. I feel like there's a couple things that we added to the sheet stuff.
Right.
That we should probably add on.
Actually, I want to work on this afternoon because one of my students, he's gone for the last 2 days,
Oh.
Southwest System in college.
Okay,
So I'm gonna give it to him tomorrow.
okay, so yeah, you could add a couple things.
Yeah,
to
look,
it.
I could work on that today. I have a break from like 1 to 4.
Yeah.
For that.
Cause the other notes are like pretty, like, they're pretty easy for me only because it's just like some weird deal.
Right, of course.
So like,
What, how long those tests take?
uh,
Is this to be ever alpha and?
he kept it pretty short.
Go ahead.
I feel like we worked around once and a half.
In an hour for. Yeah, well, all my students are near the development housing.
Really?
Yeah.
Okay.
So, I, you know, some of the actually wants to, so. Yeah, I think by tomorrow or Thursday, they should be all, you know. You know, but.
Um. Would you copy homework something yesterday or today?
Today.
Like what, like after you know?
Yeah.
There was a mistake.
Yeah, no, I think it's right now.
Okay.
Yeah, good. Right,
Yeah.
good. Kids are gearing up for next, next semester. Be ready. No, you're still doing something.
Yeah. Or. Hey, ma'am. What is our goal? Oh, there's no.
Hey.
No, you good. You good.
Now give me a sec here, guys. Hold on.
Oh, you can get him the you can get him. Figure out how. Let's see. How did that? Especially long. You're like 5'11" at best. Maybe not, not just in 16. How about you like that? Oh, yeah. 6'5"? No, that's not.
My dad knows his stuff.
That's not 6'5". Thank you. I didn't give him a call.
My grandpa is also 6'7".
I'm supposed to.
Wow, that's amazing.
Actually, do you guarantee to be over 6 when you I'm looking at you like he's gonna be 6. Your brother's like 6. I followed your dad. 6 foot. I'm 6. You're gonna be like 5. You are? I'll fix it. You'll be fine.
Okay, well, like guys would try to do is try 3 and 4. So we'll do about half of this because I think to do all 12 of these is ridiculous. We'll do 3, 4. Make sure you guys, 3, 4 is cool. We'll do 5, 6, and we'll do the algebraic techniques after that. Once that's done, I'll give you guys a homework. So you guys can work on the homework and also delta math. So if somebody want to work ahead some homework, you can. That's totally fine. I'll pass the homework in a bit. So for number 3, just make sure you get y by itself in each case. Your y is already all by itself. Hopefully, when you get y by itself for the first one, you should get x minus 3. Sorry, for the second one. Right? You are, wait. No, it should be x minus 3. Yeah, because if you move the y over to the right side and 3 to the left side, you probably got 5 by a negative. That's what I was saying. Here y equals negative 4x plus 2. And then down 4, right 1. What's common here for number 3, guys? You guys, stop talking about AYSO soccer. Okay, what's what's the point of intersection here?
1, -2.
Thank you, appreciate it. Okay, remember x equals negative 3 is vertical. Just going straight up and down. Okay, not the best line. I could do better, but x plus 2. Negative 3 common negative 1. Okay, go and try 5 and 6 on your own. 5 y is very isolated for you, so that makes it pretty easy. Oh, geez. But here you have to get y by itself.
I could watch why you just tell us. This is completely different from what it's exactly. Why it's just, yeah. No, it's so much fun. All of you, yes, that. We all have people. Yeah, you imagine. No, you didn't know about them. But still was the fact of Peter. How much of the service before? It's not your fault. It's y equals negative b plus or minus, and then the square root of b squared minus 4 times 8 times c divided by 2 times that. Oh. There's no sign that this definition.
Okay, hopefully you guys are getting this. 4x minus 9, way down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Slope is 4, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, crappy looking line. Doing my best. X minus 3 is not as steep. Looks like it touches where for number 5? 2, yeah, 2 negative 1. And also plug back in to be sure. I agree. Yep. Here you get y by itself. You should get x minus 13. Just totally off the graph. So that's kind of weird. This one, 2y equals negative 4x plus 10. We divide by 2, both get divided by 2, so negative 2x plus 5. Okay. Okay. Kind of like this problem because it's kind of hard to graph. We're gonna see a better way in just a sec, but if I try, I'm gonna try this in my head. I think it will be, you get x equals 6, comma something. Yeah, it's a tough one. I don't like this one problem. It doesn't make sense, but yeah, 6 comma negative 7. Yeah, 6 negative 7 would be true. But this is not a great technique because look at this graph. If the lines came off the graph, right? And what if it's a fraction, right? So this is not the best way to do it. So let's talk about a better way. We'll spend about 15 or so minutes talking about the better way. Then I'll give you guys a homework as well as do some delta math, and we'll be done by 11 today. So let's talk about a better way. A better way is to do this algebraically. Now, graphically, you know what's happening now. We have two equations, two variables. The point of intersection is going to be or the solution is going to be the point of intersection graphically, right? So graphically speaking, the solution is the point of intersection. And if these are lines, yeah, that's pretty simple. Now, these could be nonlinear, could be like parabolas or other weird shapes. Still the same kind of thing. You're looking for where they touch. Algebraically, you could do this. Something called substitution. I think you guys saw this in Algebra 1, I think. Okay, good. I want to make sure, because I'll have to chat with Mr. Donahoe now. Just kidding. Well, do you guys know Mr. Donahoe's father's the new athletic director at Stanford?
Oh,
Yeah, isn't that kind of crazy? Yeah, I think it's kind of neat. Anyhow, I was asking for free tickets. Anyhow, substitution, which is you replace. So you replace, which is going to do 4x minus 9 equals x minus 3. Because what I just do, I replace the y in one of the equations with the other value or other expression. So maybe this y got taken out, and I put x minus 3, or this y got taken out, I put 4x minus 9. Regardless, you're doing a replacement, right? That's all you're doing. You're doing a replacement. You're replacing a variable with an expression. So 3x equals 6, x equals 2. Then y equals 2 minus 3. So y equals -1. So you get 2 comma -1. Make sense? Okay. Okay. Let's try it again for number 2. I'm gonna have you guys try a couple. Let's see how many we got here. Yeah, I'm not gonna do all 8 of these. That's just too much. Oh my gosh, 10 of these? That is bonkers. Yeah. So we'll do like a couple after I finish number 2. And then we'll do a couple of the elimination. Then have you guys try a couple. And then we'll do this other work. So what you want to do is get y by itself. Now, what I recommend, or x by itself, it's up to you. What I recommend is get something by itself so you avoid fractions. Should I get x by itself in the first equation? That would involve fractions, right?
no, give
Yeah, I wouldn't do that. If you try to get y by itself in the first equation, but let's get x by itself. We saw this already. We already did this problem. We graphed it. Let's get x by itself in the second equation. Then you're gonna do this. 4 parentheses plus 2y. So what I just do, I isolated one of the variables, one of the equations, chose some avoided fractions. And trust me, if I do ask you a question like this on a test, if you're having as a teacher, I would make sure if I ask you to substitute avoided fractions, that's just nasty. Right? Okay. So I got x by itself in the second equation, and then I replace x in the other equation. So I'm not gonna go back to the second equation again, because I'm spinning my wheels. Gonna put it back into the other equation I've not used yet, and work it and substitute. So I'll do it in green so it stands out. Y plus 13. Okay. Now you work it out. Then what you do is you throw it back into any other equation to solve for x. Probably back into the x equals y plus 13 equation. And then I got 6 comma -7. So you gotta be very methodical when you do these kind of problems, and you usually want to express the answers in order pair, right? Because that's what it is. It's a point of intersection. So now we have you guys do try 3 and 4. Three should be pretty easy. Y is very isolated. 4, you probably get x by itself in the first equation. So it goes a shot. I'll come around, make sure you guys are doing okay. Feel free to use a copy for YouTube. So let's go ahead and substitute replace y. The second question for 5 was -5. Gosh, so many classes. And then 4. Okay. X equals -7y. Yeah.
Oh, wait, fucking so.
And substitute.
Stupid, I added 40 to 20.
So let's go and substitute. Work that out. Hopefully x equals 0. We plug -5 for y into the second equation. And then y is already -5. You already know that. So all's good there. Here x equals -7y. So 2 times -7y. Y is -1. X equals 7. So that's called substitution. Just get one letter by itself, one equation, substitute the other. That's it. And just make sure you use your algebraic skills, distributive property, whatever, all that stuff correctly. Should be fine. Questions on 1, 2, 3, 4? And again, let's not do 5 through 10. That's just crazy. So let's go to the next page. Let's do 11 through 14. And again, we're not going to do 15 through 20. It's just a little too much again. But we're going to do another technique called elimination. Once we finish that, then you guys can work the homework and more delta math. Okay. So 11 through 14, here we go. Elimination is exactly what it means. You're eliminating a variable. You're getting rid of the x or y. It's your choice, right? So usually what I like to do is get into standard form. Okay. Geez. Get into standard form. Now, standard form, in case you forgot, is this. Looks like that. AX plus BY equals C. So it helps to get all the variables on one side and the number on the other side, which I have here. Then what you probably could do is you want to eliminate one of the variables, right? So what I'm probably going to do is for this equation right here, multiply both sides by 2. So comes 16x minus 12y equals -40. And then for the other one, see how those just, if I add the equations, see how those go away. That's called elimination. So I deliberately chose one variable to have an opposite sign with the other variable for the coefficient. So you have -16, maybe the one +16. By the way, you don't have to have them opposite signs. You can have them the same sign, but then you subtract. Like, what if I multiply the first equation by -2? Both sides. Then I'd be subtracting that with the second equation. But personally, I like to have opposite signs, so I'm adding. Because -12 plus 7, that's pretty easy. It's -5y and -10. You should get y equals -2. Once you get y, then you could plug back in either equation, solve for x. It's kind of up to you which equation you decide to go with. Bless you. So 8x so x equals -4. You can plug in either equation, wouldn't matter. You still get x equals -4. So the answer is -4, comma -2. So here's what I'll have you guys do. Try 12 and 13. I'm gonna do 14 with you guys because 14 is a little funny. But let me give you guys a few minutes to try 12 and 13. So I'll give you about 4 or 5 minutes. Try 12 and 13. Then we'll do 14 together. And at that point, you guys can use the rest of the class for Delta Math or homework. So kind of prime this for you guys in a little bit. Hope that makes sense. I got this set up.
So you should easily solve for y after 12 and get x afterwards. Easy solve for x and then 13 and solve for y afterwards. So if you guys make your mess, I'll pause the screen and
Get the answers done in here. There we go. Okay. Mhm.
No, they don't have to be, no. You can do opposite signs, then you're adding the equations. If they're both the same sign, you subtract. It's your choice.
Oh,
So like I could have multiplied the second equation by -2 to get -12x minus 10y equals -4. But in that case, I'm subtracting. I don't like doing that because I'm subtracting a lot of negatives, and that's easy to make a careless mistake. You can.
Yeah.
No problem.
Okay.
I just try to avoid, that's my own personal preference, so, yeah.
Okay, so in about a couple minutes, we'll check in, then we'll do 14.
You had him on his son. That's what I said. No, is it the color of the front, or it's like, there's a whole. Sometimes the one of the dead foundation. Yeah. Not one of the things is she. So is there someone that fits you at the wall? More investments, so you figure out about the whole. I wasn't sure what to do. So it's such a
Okay, let's go to the answers. We'll do the last one. So you got 2, -1, 7, -8. Cool. It makes sense. Plug it back in to each just so we can verify. Okay, last one we'll do. You get the point because you don't have to do so many of these here. Last one, 14. That's kind of wacky the way it's set up. So I'm going to rearrange each of these. I'm going to say for the first equation, I'm going to write as 8x plus 12y equals -24. Now the second one, it's got fractions. You do not want to deal with fractions when you deal with this stuff. You trust me, don't. So I'm gonna get rid of the fractions. For the second equation, what should I multiply both sides by so I can eliminate the fractions? What's the least common denominator of 9 and 18? 18, yeah. So you gotta know your fractions pretty well to be able to do a problem like this one. So I do that, I get 18 plus 10y? Yeah. Equals negative 7x. If I move things around, I should get 7x plus 10y on the left side and negative 18 on the right side. Okay. Okay. Still not out of the woods yet. Your choice. You get rid of x or y. Which one I get rid of? So that's up to you. Y. Okay. 12 and 10. What number can 12 and 10 both go into? What's the least common multiple of 12 and 10?
5.
Close. Really close. So 10, 20, 30, 40, 50, 60. 12, 24, 36, 48, 60. Yeah, so sometimes you can just list them out like that, use your fingers, that's totally fine. So you want 60 for each of those. You're close, you're close. So I'm gonna multiply this by 6 and 6. And multiplies by 5 and 5.
12. Not seeing us.
You were? Good. All right, so you should get 40x. You might need a calculator at this point because the numbers get pretty large, but I'll just do this in my head for you guys. It's negative 120. And 42x plus 60y equals negative 108. Now, in this case, I'm going to subtract the two equations. In order to protect myself, I'm going to put parentheses here. So it's protected. So I get negative 2x equals 12. Negative 12. So x equals 6. To do substitution would have been kind of crazy. And I've seen people try doing that because they don't know the elimination, don't want to do it. They go as fractions to spin the wheels or do some crazy stuff. No, easier to do it this way. And then lastly, if I want to get y, I can do either equation. Maybe the first equation is probably easier to work with. Negative 24 minus 48 equals 12y. So y equals negative 6. So 6 comma negative 6. I think that makes sense. Yeah, I'm pretty sure it does. So yeah. But with Desmos, you can always do some Desmos to check the answers. Sometimes, just so you know,
If the lines are parallel, would be no solution. That would happen if all the variables went away, and you had a number on the side that's not 0. That'd be no solution. Or you do the same line, infinite solutions. Everything goes away on the left side and the right side. That's how it looked.
likewise a substitution, you have 0 equaling a non-zero number, or for no solution, 0 equaling 0 for implementing. Just want to just say that, just so you've heard it from me. But anyhow, so we got about 10 more minutes left. Why don't you guys get a head start on the homework?
It's right here. Or if you want to do more delta time, do that as well. It's just, pretty simple.
What do you think of-